In order to use an OOP paradigm in JavaScript, we need useful patterns for creating objects. Otherwise, every object we create, we are creating from scratch, which is very inefficient. Think about our example, reserving rooms. We would have to create each room from scratch as an object, add the necessary properties and methods to that object, and it's just not an efficient way to do it. JavaScript provides several patterns for doing this. In this section, we're going to be looking at the three most common: factory functions, constructor functions, and classes. We're going to take a look at factory functions first. A factory function is simply a function you call that returns an object. It is as simple as that. This particular pattern is probably the simplest of the three to think about and reason about. Let's take a look at it for generating objects we need for the reservation example I introduced earlier. So first thing I want to do is set up a function. And I'm going to call it create room. Since that's what we're doing in this function, we're going to have it create these different room objects. Now, we could have multiple parameters here for passing in data to create these objects. I'm going to keep it simple, like I indicated. We want to focus on the patterns more so than on the actual code to make things work. So name and capacity, I'll put those two in there. Those are two pieces of information we want on each object. So that's why I'm putting it in there. So the idea is that we pass in the data that we want in the object, and then the function itself returns an object with that data. And it may have additional properties and methods as well. That's the idea of a factory function. Pretty simple. So right here, the first thing we want to do inside of this factory function is return, and return what? An object. There we go. We have our object. Right now it's an empty object, but we have our object and we have our factory function. So now we can begin setting up the properties that are going to be a part of this object. We want a name. We passed in name, so we could do something like this, and a capacity, something like, let me spell that right, something like this. Oh, spell it right there. Now that would work for us great, but we're typing more characters than we actually need to. If we're going to be using a property of the same name of the parameter that we're passing in, well, we can set that up like this. We don't need to specify the property name and then the value. We simply specify the parameter, the variable, and it will create a property using that name, and then it will put the value for it. So much simpler to set up. All right, let's add another property. We want to be able to indicate if it's available or not. Say maybe sometimes these rooms become unavailable, and so we want to be able to set that default, so whenever somebody checks for it, it'll automatically see it's not available no matter what this schedule says. So we'll do that, and then of course we need a schedule. Now this could be a pretty complex part of the object dealing with the schedules. I'm going to keep it simple. I'm just going to have an array that's going to store a schedule. I have a date object in it, and then I'll have a length of time. That's basically all it's going to do. Now let's add a method. So this is a reserve method. I want a date time object passed in, and then a length in numbers, and that should be minutes, how long it is in there. Now let's talk about this for a minute. This is where one of our pillars of object-oriented programming would come in, and that's abstraction. This reserve method could be quite complex. We may have to adjust a date and time coming in different formats and make it work in the reservation. We may have to deal with lengths of different formats depending on what we make possible. All of that complexity can be hidden inside of this method, and so that's the abstraction. We make the calling of the method simple as possible. All the details are behind it. They're abstracted out of the way. Now, like I said, I'm going to keep this simple. All I'm going to do is this.schedule.push, And what are we going to push there? We're going to push an object. It's going to have DTM and the length. Now notice how simple I'm making this here. I'm using what's passed in, making an object out of it. I'm doing the same thing I did up here. So I'm using the variable name to give the property name, and then it will assign the value to it. Same with length there. All right, so we have our first factory function. Now, to use a factory function, we would set up a variable, and we call the function like this. In this case, I'm going to pass in the name and then a capacity of, let's say, 20. This is a bigger boardroom. So there's our name and our capacity. Let's just take a look at that really quick. I'm going to save that. I have the server extension running, so let's just go to, make that smaller a bit. I'm going to go here and go to the console, and let's take a look at boardroom and see if we've got something. And here's our first object. And notice with the capacity and name how it created the property and then it attached the value. And here's our method, and then here's our schedule, just an empty array right now. Well, the advantage of setting up a factory function is we can create multiple objects, and we would have multiple objects for this scheduling. Every room that we would need available would be an object. So let's just create one more. We'll call it a training room. Training room A, I guess. And we'll create a room, and let's just give it a name like that. Capacity, let's say it's 35, something like that. So there's our second object. We now have two objects that we've created. If we come out to the console here, we can see both of them. There's training room A. We can see that its information is different. So I want to mention another pillar of object-oriented programming now, and that's encapsulation. We have data in this object. This is also the state of the object. This data identifies the state of the object. And then we have methods, at least one method here, that acts on that. It acts on specifically the schedule, this particular method here. We can have other methods that would act on different things. Maybe we have a method that changes the availability or something like that. But this is encapsulation. We've encapsulated those things into a single object. Now let's take a look at reserving something. So if I do boardroom.reserve and call that method, I'm going to set up a new date. This is how I want this done. Let's see. Looks like I've done that previously, so let me just choose that so I don't have to type it all in. So here I've created a date. I'm passing a date in for this method, DTM, and then a length of 60. And I go ahead and press return. Now if we take a look at boardroom, now in our schedule, we have one item in our array. So if we look at it, we can see that there is a date in there and a length of time. So there we have our method acting on the state of that object, changing the data. Now, so far for all of the objects, or the two objects we've created, that's all we've created so far, the methods have been embedded directly on the object. Now, since every object needs to share certain methods, for example, the reserve method should be something that's available on all of those objects. It makes sense to have those methods on a prototype and not repeating them on every single object. So how do we use a prototype with a factory function? Well, that's what we're going to be looking at next.